All right, we're going to look at some problems from section 9.2 on arc length and area of a sector. And if you recall, we looked at these in class in two different ways. One is that we look at it as a portion of a circumference if we're looking at the arc length. And the other is we use a formula. So our formula for arc length, we label S, is r times theta, where r is the radius and theta is the angle measurement, but it has to be in radians. So here, our angle measurement, our central angle is 30 degrees. So 30 times pi over 180 gives us pi over 6 radians. And so now the arc length will be 13, the radius, times pi over 6, or 13 pi over 6, and our units are the same as the units of our radius, inches. Okay, next one here, we have the essential angle is 3 pi over 4. Give me 1 second here. Okay, so we're going to do this one a little differently. Rather than use the formula, we're going to say, well, our circumference, right, which is 2 pi r, which would be 2 pi times 11. So we have 22 pi. Okay, so what percentage do we have here? Well, we know our angle measurement is 3 pi over 4. And the total circumference is 22 pi. I'm sorry. All the way around the circle, in terms of our angle measurement, rather, is 2 pi radians. All right, so we have radians divided by radians. And so that actually is 3/8 of the circle. Okay, so we have 3/8 here, so that would be 3/8 then of the circumference. So our arc length would be 3/8 times 22 pi, and we can simplify that after multiplying 66 pi over 8. 2 divides into each, and we get 33 pi over 4, and here we are in meters. So two different ways to look at it. We can use our formula, which here is S equals r theta. Again, theta has to be in radians. Or we can look at it as what percentage or what portion of the circumference do we have? And again, our central angle is 3 pi over 4 radians. A complete rotation is 2 pi radians, so it's 3/8 of the full circumference, and then multiplying the 3/8 times the 22 pi, which was our circumference. Okay, so let's come down here, and again, we have a formula, and our area formula is 1/2 r squared theta, and we can use either this or, again, similarly to what we did here, and I'll do that here for this first problem, we can look at it as what percentage of the area of the circle do we have? All right, so area of a circle, right, pi r squared. Our radius is 18, so our area would be 324 pi. Well, we have 90 degrees, right? And we have a complete circle is 360. So that means we have 1/4 of our circle. So we would have 1/4 the area. So the area of our sector would be 1/4 of the 324 pi, which would give us 81 pi. Okay, in this problem, we'll use our formula. So area equals 1/2 the radius squared, so that's 16 squared, times theta. Now we are already in radians, so we don't have to do any converting. And when we simplify all that, oh, I forgot my units here. So that would be meters squared, right? There's our meters. Area is a square unit. This would give us 192 pi yards squared because our units are yards. All right, hope that helps, and we'll see you soon.